Our objective in this section is to be able to use formulas for lateral and surface area of three-dimensional objects to solve real-world problems. Let's begin by reviewing what area means. Area is the space covered in two dimensions. And we always use square units, which can also be written as units squared. Think of covering, like what you might do if you paint something, or color, or tile. Think of flat. Now apply that concept to a specific kind of area, surface area. Surface area is the sum of the area of the faces of a solid. It is also two-dimension, but the solid is in three dimensions. It is also area, so it is unit squared or square units. Remember, sum means add or total. Think of covering all the sides and top and bottom of any object, of an object, covering all the surfaces. The sides and the top and the bottom are all of the surfaces. Often, if we do things like wrap a present, that is covering all of the surfaces. Painting all of something or the entire surface of an object. Then we have the lateral area. Again, this is an area, but lateral means side. So we're just adding up, finding the sum of the area of the lateral faces. Lateral faces, think of the sides. The lateral faces of a solid that has a base. It's also a two-dimensional measurement, and it's also in square units because of its area. Think of if you have to cover the sides of something, like a can label. The label on a can, it just goes around the sides. Or if you don't want the base, or you don't want the top and the bottom of something, you just want the sides. Lateral means sides. Let's look at a few examples that apply these types of measurement. Number one, a square pyramid that is 4 meters tall has a base that measures 6 feet long. How many square feet of paint are needed to cover this entire pyramid? So the first thing I noticed, some keywords here. Square feet indicates a need for area. Square units is area. Paint is another indicator of a use for area. Covering is another use for area. Now, a pyramid is a three-dimensional object. See the picture? But if I want to cover the entire, I want to cover it, all of it, then that's going to be all the surfaces or the surface area. So I go to my formula sheet and I find the pyramid and I go to the surface area formula for the pyramid. Now I need to put measurements in here from the directions. 4 meters tall. So this part right here is 4. The height is 4. The square refers to the base. Square means the base is square. So if it says 6 feet long in the base, then this side is 6 and this side is 6. Let's go ahead and write down the formula that we extract from our formula sheet. Surface area equals 1/2 LP plus capital B. Now to use the formula, we have to know what these letters represent. So let's start figuring out what we have and what we need. We need L. Looking in the picture, the L comes down this side right here. Well, if I want that and I don't have that, because that wasn't given to me, by the way, that L is called the slant height. Not that I need to know what it's called, but I need that length. If I need that and I don't have that, let's use other things we have. The height that is 4 comes down at a right angle to halfway across the base. Well, the length of the base is 6, so halfway across is 3. Notice that picture that we have right there? That's a right triangle. 3 here, 4 here. How do we find that missing side? Pythagorean theorem, c squared equals a squared plus b squared. C is that missing hypotenuse, which we're calling L, the slant height. So L squared equals 3 squared plus 4 squared. Now, if you know your triple, 3, 4, 5, it's a lot faster. L equals 5. So we can put 5 in for L. Now I need P. P means the perimeter of the base. Well, if the base is this square and it's 6, 6, 6, and 6, how do we find the perimeter? Add up all the sides. 6 plus 6 plus 6 plus 6. All of that together, our perimeter is 24. So 24 in for the perimeter. Now I need capital B. Capital B means area of the base. So again, area of the base. The base is a square, so the area of my base, or the area of my square, is length times width, or side squared. 6 times 6 is 36, so that's the capital B, 36. Now I have all those measurements, I can plug it into my calculator and compute that surface area. We get 96. I need units. I see feet were given, and anytime that it's area, it's units squared. So my surface area is 96 square feet. That's how much paint I need to cover the entire, all of it, the entire pyramid. Now in part B, it asks how many square feet of paint are needed to cover the pyramid, but not the floor. So I don't want not the base. So that means I want just the sides. And if I'm referencing sides, that means I want lateral area. And I know it's area from these same keywords. Square feet means area, paint means area. If I'm using it to spread on something, if I'm using it to cover something. So let's go to our lateral area formula next. Lateral area of the pyramid equals 1/2 LP. Now notice that's exactly what we did already, but not the area of the base. Remember, not the floor. So I'm just going to plug in the information that we got earlier. Half of the L that we got was 5, and the P that we got, the perimeter of the base, 24. So just computing that makes 60. It's still area, so it's still square feet or feet squared. Number 2, find the surface area for this ice cream cone. So notice this is made of 2 shapes. We have a hemisphere on top and a cone on the bottom. I want the surface area, so let's do this in parts. The hemisphere, which is on top, means half of a sphere. So we find our sphere formula from our formula sheet. I want the surface area. So the surface area of the hemisphere, or the sphere to begin with. So I want the surface area, but half of it. Half of 4 pi radius squared. So half of 4 times pi, r is just half of the way across. That's 4 squared. When I'm not to the final answer, I'm not going to type in the pi just yet because I don't want to round too soon. So half of 4 is 2. 4 squared is 16. 2 times 16 is 32. So this makes 32 pi. Now let's do the cone. The cone has a surface area formula that looks like this. However, notice that the hemisphere is sitting on top of the cone. So normally, whereas the surface area of the cone covers all of the surfaces, including that circular part, because the ice cream cone is on top, I don't want that part. So I only want the sides, the area of the sides. And if I only want the area of the sides, I don't want surface area, I want lateral area. So I'm going to use the lateral area for the cone, pi r L. What is the L? The L is this slant height. In the picture, what do I have? From the top straight down to the bottom, it says 12. The radius makes a right angle with the height, it says 4. The slant height I don't have, but I can find that. If we have a right triangle and I'm missing just one of the sides, Pythagorean theorem. C squared equals A squared plus B squared. Let's compute that. 16 plus 144, 160. Take the square root and we get a decimal. So I'm not going to write the decimal, I'm going to write it as square root of 160. So let's go plug this stuff into our formula. Pi, the radius is 4, and the slant height is the square root of 160. The best I can do for this lateral area is 4 pi square roots of 160. Now I can put these two together. So for my final answer, I'm going to take this plus this. So put them together. So in total, my total surface area, 32 pi plus 4 pi square roots of 160. Let's type that in all at once with the pi and everything and get approximately 259.5. Now I'm using centimeters and this is still area, so it's centimeters squared. That is pretty exciting when we get it all put together. Let's try one more. You're wrapping a present in the shape of a triangular prism as shown. Find the minimum amount of wrapping paper needed to cover it entirely. So covering is a keyword for area. Wrapping something is a keyword for area. Entirely indicates that we probably want surface area. Now this is a triangular prism, so from our formula sheet, we're going to the surface area formula for the triangular prism. Let's write that down. Surface area equals HP plus 2 capital B. Let's see what we have. In the picture, the H is the length that connects from triangle on top to triangle on the bottom. It connects the two triangles. Well, in our picture, the part that connects the two triangles is this length right here. See this triangle in the front and this triangle in the back? This connects them. So whatever connects the two triangles, that's what the height is. In this case, it's 10. So in for height, we put 10. Now I need P. P represents the perimeter of the base. Remember that the base is a triangle. So the perimeter of that is adding up all the sides. Well, I don't have all the sides of this base. So let's find it. This is 12. Oops. 16, this is 12, and I'm looking for this missing length. So let's do our Pythagorean theorem. C is the one that's missing, our hypotenuse. And if we think of it as our missing 3, 4, 5 triangle, 3 times 4 is 12, 4 times 4 is 16, 5 times 4 is 20. That's a faster way to get to our missing length of 20. So our perimeter is 12 plus 16 plus 20, or 48. So 48 in for our perimeter. Now we're going to add to that 2 times capital B. Well, capital B means the area of the base. Well, if the base is a triangle, then I need the area formula for the triangle. And we're usually going to use this one. So that's going to be 1/2 times the length of the base times the height. The length of the base is 12, the height is 16. So 1/2 times 12 times 16 is 96. So in for the area of the base, 96, which makes 672. Now this is area, and I'm using centimeters, so centimeters squared. I'm going to conclude now with this nice little video that might help illustrate these different types of measurements. See you in class.